And good morning. Hello from Ottawa in Ontario, Canada, and welcome to the MuxLab webinar on the Dante solutions sponsored by Sherpa. My name is Jose Mosota. I have a training company, Fremont Solutions, that focuses on creating and delivering AV content for the professional AV market. I hold a CTS and a CTSI certification from AVIXA, and I'm also a member of the AVIXA faculty. I'm an AVIXA trainer. I'm a certified HDBaseT trainer. I have Dante level certifications 1, 2, 3, and domain manager. I'm an SDVOE design partner, and I hold a Google cybersecurity certificate. And I'm really happy to be able to be here today to share with you some ideas about the technology of Dante, and also to review the ecosystem that MuxLab has created around Dante. If you have any questions, please, the best way to do it is use the chat, because then I can see the questions on my other screen and I may answer them the moment that they happen if they are relevant to understanding a particular point. The goal of the webinar is, number one, to review audio encoding. How do we turn an audio analog signal into a digital signal? And it is important to understand how do we do audio encoding, because when you use Dante, Dante is not only a black box that you're going to connect something in and you're going to get something out. There are choices that you can make when you use Dante to transport an audio signal on a network. And those choices depend on your ability to understand how do you encode an audio signal. And after we understand audio encoding and we have an introduction to how Dante works, we're going to review the Dante solutions, because you will have enough elements to actually realize what MuxLab can offer you and how you can use those solutions. And please participate. If there are any questions, there are no wrong questions. The only wrong question is the one that nobody asks. So don't hesitate on asking any questions that you may have related to the material. The agenda is as follows. We'll look first, how do we go from analog to digital audio? Then we're going to discuss how does Dante work. We're going to take a look at two very important pieces of software. The heart of a Dante system is the Dante controller, and the tool that Dante developed more recently that allows you to expand that control is the Dante Domain Manager. After that, we're going to mention AES67, which is very relevant when you try to transport audio on a network. And I say here that is your best friend, and I'll tell you why. And at the end, we will look into the MuxLab Dante solutions with a little bit of detail. So audio signals become digital by utilizing what is called a pulse code modulator encoder, or an analog to digital converter. You have an analog signal, the audio on the air being captured maybe by a microphone, and that is a signal that varies constantly in amplitude over time. In order for us to convert that into zeros and ones, because networks only understand zeros and ones, networks work on the digital system, we need first to sample that signal, and we turn that signal into a pulse amplitude modulated signal, which is a series of pulses that determine the level of the signal at the time the sample was taken. Then after having the pulse amplitude modulated signal, we superimpose it on top of a grid that relates those values to a series of bits. The more bits that we use to actually quantize the signal, the more detail we're going to get, the better is going to be the reproduction of the analog signal in the digital world. But as we will discuss, the more data we have to carry, the more bandwidth we have to manage. And then finally, after we have converted the signal into zeros and ones, this red box here is inside our network interface card, or the network interface card of the Dante boxes, and is the one that manages to put the zeros and the ones on the wire so they can go to the switch and travel around the network. So there are two parameters that we have to understand when we quantize audio in a digital manner, and that is the sampling and the quantification. The sampling was solved to us by two very smart people, Nyquist and Shannon. They created a theorem that proved mathematically that if you sample a signal at twice the highest frequency, you get a good enough digital reproduction of that signal. Since we can hear from 20 hertz to a maximum of 16, 20 kilohertz, then a sampling rate of 44.1, which is double, a little bit more double than 20, it's enough. However, most audio to digital devices will offer you rates of 96 and 190 and 29. I'm sorry, 192. There's a mistake there. Can be used, and that is because audiophiles claim that you need to sample at higher rates to get a better reproduction of the signal. And if you listen carefully to both signals at 48 and 192, for example, and you have a good hearing, you will certainly hear some certain differences in the quality of the sound and the quality of the music. The graph here shows you that if I have a signal, in this case a sine wave, and I actually sample the signal at twice the frequency, which is 2 samples per cycle, I get a relatively decent reproduction. That's what Nyquist-Shannon indicates. If I do it at 4 times the frequency, 4 samples, I get a better reproduction, but I have to transport more data. And as you know, one of the issues when we work with networks is the bandwidth availability. So it is always a balance between how much data can I transport and how accurate is it going to be the digital representation of my analog signal. If instead I only sample it at the frequency of the signal, I get something that doesn't really resemble the original signal. After that, once I have that signal converted into pulses here in green, then those pulses need to be converted to bits, zeros and ones. And the number of bits that I use on the grid to convert that gives me also a better reproduction of the signal if I use more bits. So if I use only 4 bits, I would have only 16 levels that I can use. And as you can see, there's quite a distance between one level and the other. So typically we don't use 4 bits when we actually quantize an audio signal pulse amplitude modulator. We use 24 bits, and recently audio to digital equipment also allows you to use 32 bits. And for that, you have millions and millions of options. That means that the levels here are quite close to each other, but can accurately represent any signal that you want to represent. So when you combine that, the sampling rate and the bit depth, what you have is that more of each gives you greater fidelity. However, more of each also gives you an increased bandwidth usage. And if you increase the sample rate, then there is fewer channels that you can carry on one wire inside your network that you are using to transport that digital audio. For example, if you utilize 48 kilohertz of a sampling rate and you use 24 bits for your bit depth, and you have 64 channels of audio that you want to carry, that takes you about 74 megabits per second. With the overhead comes close to 90, 100 megabits, which is relatively easy to transport on a regular network. But if you increase the sampling rate to 96 for the same 24 bits, 64 channels, you end up with 160 megabits. And if you go to the extreme of 512 channels, then you definitely need to use 48 kilohertz. Otherwise, you would exceed 800 megabits, which is 80% of a gigabit network, and that is not recommended to do it. So that balance is important. And when you use Dante, you will have the opportunity to select the sample rate and to select the bit depth. And what do you select will be based on your bandwidth availability, and also on the application that you have and what do you want to get out of that audio transport. So to calculate the bandwidth of a digital audio signal, what you do, you have to multiply the sample rate, and in this case, for example, 192 for DVD quality audio, by the bits per sample. DVD quality audio is typically done at 24 bits per sample. The number of channels, if you have DVD audio, you typically have a 5.1 type audio with 6 channels, and that gives you 27 bandwidth in megabits per second for those 6 channels. So that's not a very large bandwidth. That is why audio was the first part of audio video that was transported on networks. It took much longer for us to be able to fit video into the network because video has much more bandwidth than audio, but while audio overall can be transported, and it's typically transported also without any compression. So when we transport audio, we do it uncompressed, and we don't lose anything of the quality of the audio by having to compress the signal, and that is due to the low bandwidth of an audio signal compared to that of a video signal. Now, what is Dante? So Dante is a proprietary audio and control transport system that recently has also expanded into video, but today we're talking about Dante Audio. It is proprietary because it was designed by a company in Australia called Audinate, and they are the creators of the chip that are at the heart of the Dante solution. And we don't really know what happens inside those chips. That's the proprietary part, that is their secret, but essentially is the most popular solution in the market. There is more than 6,000 people that are putting out products based on the Dante chip in the market continuously. It is a fully routable protocol for transport or solution for transport. That means that it can go on layer 3, it can go through routers, which is something that is quite recent for Dante. In the past, it was kind of difficult to route Dante, but since the release of Dante Domain Manager that we're going to talk about, they solved that problem, and right now Dante is fully routable. That means that you can send the audio from one subnet to another subnet through a router. It does require a minimum of 100 megabits of switch Ethernet network, and the reason is, as you saw, that you have a relatively low bandwidth for the signals. However, I would say that nowadays, most likely, most networks that we're going to deal with are gigabit networks, so they're going to be pretty comfortable carrying any amount of audio that you need to carry. It does require gigabit, definitely, if you're thinking about video, but that can be for another webinar. It doesn't require dedicated bandwidth, so it is a protocol that when we implement it on a network, it doesn't go out and tell the network, I need to reserve the bandwidth for Dante. That's a benefit compared to other systems, like, for example, audio-video bridging that requires dedicated bandwidth and creates issues for any other applications that are running on the same network. It can run over any Ethernet topology, so you can do star, extended star, mesh, partial mesh, etc. However, it does not allow you to utilize Wi-Fi, simply because Dante is very strict at maintaining the latency of the audio signal as it travels the network, and with wireless that would not be possible. But it does allow you to use the Dante controller to control the application through a wireless connection. Like we said, it transports the audio 100% uncompressed. It allows you to choose sample rates from 44 kilohertz to 192 kilohertz. It allows you to choose a bit depth to quantize those samples from 24 to 32 bits. It has a maximum, if you have the largest possible Dante system, of 512 channels of audio for each Dante device. So one connection between that device and the switch will be able to carry 512 channels of audio at 48 kilohertz, 24 bits. For administration, Dante uses two softwares. One is Dante Controller, and the other is Dante Domain Manager, and we're going to talk about both of them. Dante also has a virtual sound card that allows you to turn your PC into a Dante machine. So essentially, you connect that through a USB port to the PC, and the PC, the laptop, whatever device you have, then becomes a Dante endpoint to send and receive audio. And then it has an application called Dante Via that allows you to use your PC to do more mixing, selection of sources, etc. It's a more complex solution for customers that require it. If you actually have signals that you want to put into Dante that are actually coming from other systems, and they have maybe a different sample rate than the one you have selected for your signal, that conversion can be done on Dante hardware. If you have different bit depths, that can be done by software. So there's a lot of flexibility accepting signals that are different from the ones that you already have. And it gives you the possibility of doing redundant networking, because many Dante devices, not all, but many, have two ports, which allows you to have a primary and a secondary network, so that you're guaranteed that you're never going to lose the network service for your audio. The heart of the system is the Dante controller. The Dante controller is where you define all the connections that you want to make between the Dante encoders or senders and the Dante decoders or receivers. The Dante Discover is automatic. When you connect a Dante device to a network, it automatically announces that I'm here. It says, hey, I'm a Dante transmitter, and I'm available if you need me. And that gets recorded in Dante controller, and every Dante device in the network is aware that that device is connected to the network. That's done with the protocol MDNS. The latency can be set by the system administrator, but typically, unless you do it by default, is no more than 1 millisecond. So the signal for Dante is really almost has no latency, considering the amount of time that 1 millisecond represents. You can configure some network paths to allow more latency, and that will allow you to configure other network paths to allow for less latency if you need it. It has a maximum of 10 hops, so that means that if you're using a large system with many switches, you can have as maximum 10 switches in your system, and that is due to the fact that after that, you start losing the timing and the latency precision that you require for Dante. Dante can do multicast. You need to enable IGMP in your switch to do multicast, and it handles it in a different way than the traditional multicast, but it's a Dante multicast system, and you can learn about it in the Dante certification. And something very important, once you set up your system and you use Dante controller, you can name your connections, and after you name the connections are using those names to be recognized in the system and not IP addresses. We solved one of the problems sometimes we have with networking AV systems, and that is the use of a DHCP server that hands out IP addresses. We then go and create our architecture, our connection between transmitters and receivers, utilizing those IP addresses given out by DHCP. Then the DHCP server goes down for whatever reason, and when it comes back on again, the IP addresses change and we lose that configuration. That cannot happen with Dante. With Dante, once you set up the system with Dante controller, all the connections have names that you give them the names, and those architecture connections of Dante transmitters, Dante receivers are done based on those names, so they don't care if an IP address changes because the DHCP server was not available or had an issue. This is an image of Dante controller. So if you load Dante controller in your computer and you turn it on connected to the network that is running Dante, you will see this kind of an image. And it is fairly intuitive. Obviously, there are manuals and trainings, but you can probably realize looking at this image that is fairly intuitive. You see all your Dante transmitters here. So you have your Dante transmitters with the names that you gave to those transmitters. And if you click on any of them, it shows you all the possible connections that the transmitters have. It also shows all the Dante receivers. And again, you can click on each of them and see all the channels that they actually have. And in order to create connections in Dante, in order to say, I want this signal for the transmitter to go to that particular receiver, all you have to do is go to the point where that transmitter and that receiver cross to each other and click on that point. If you click on that point and you get a green bubble, that means the connection is perfect and it will happen without any problems. If you get a red bubble, Dante is telling you, you have to look into this because this is not going to work. Something is wrong here. And if you get a yellow bubble, Dante is telling you this is going to work, but please check what you're doing because it may have some issues. So it is extremely powerful in terms of giving you feedback as to what is happening with the connections that you're trying to create. You can see here that you can also look at information like sample rates, latency, to which multicast you have subscribed, if it's AES67 compatible that we're going to talk later on. It also shows you in which domain you are. So we're going to talk about domain manager, where you can divide your Dante network into subnets, into domains, and you can actually run one Dante controller in your computer, and by selecting the domain on the domain selector, you can control all the domains one by one, because the domains remain like a separate Dante network, each one of them. You also have a user guide online, so it is very, very powerful. This tab is the routing tab, so it shows you all the connections. You can also look at device info, at clock status, at network status. Everything can be done from Dante controller. For example, on the device view, you will get the opportunity to select the sample rate. You get the opportunity to select the encoding. You get the opportunity to select the latency. So again, extremely powerful, extremely intuitive, extremely easy to use. And this would be kind of a large Dante system for a band that is touring, and they're going into a venue. And they have radio microphones, so they have radio receivers that are Dante capable, and the signal from the radio receiver goes into a switch to get it into the network. You also have wire microphones that are connected to stage boxes that are also Dante capable, and those stage boxes will then go into the network as a Dante signal. And once you have those signals into the network, you can route them anywhere you want. You will have a PC running Dante controller, or some kind of a laptop or iPad running Dante controller, and that allows you to make all the selections that we already discussed. And connected to the switch, you have, for example, here front of the house. So front of the house will be able to get all those signals, do all the mixing that they need to do, and from there they'll come out with the mix signal that they're going to broadcast to the speakers, and that could go then through a DSP processor that is connected to the network, or it could go directly to the amplifiers, and from there they could go directly to the speakers. On the other hand, you could also be taking another signal to go into a monitor mixing console, where you're going to do more fine work and maybe do a recording of what's going on and listening through it with monitor wedges. So that will be a complex kind of system, but on Dante you can go from the simple two-channel system that we're going to discuss later to something like this very, very easily, just by adding equipment to the network. Now, Dante recently, about 2 years ago, developed Dante Domain Manager, and they introduced Dante Domain Manager to allow you to have more control over the different parts of a system on a Dante deployment. For example, when you have a venue, and in that venue you have a rental system because people come in with their own equipment that they want to hook up to the network. You also have a house system on the network that you use for the shows that you actually do on your own in that particular venue. There is also an evacuation system that is used for emergency directions and to tell people where to go in case of an emergency, flashing lights, sound, etc. And there may be also a paging system that you utilize to communicate with people that are working on the venue and letting them know that they are needed somewhere. Well, by using Dante Domain Manager, you essentially can break these 4 systems into networks. You can break them into subnets. You can connect them to the Dante Domain Manager and through the use of routers. You can actually manage these 4 systems like if they are different systems, and you can actually control them in more detail. You can give them more control of everything that is happening in each one of those systems. You can allow the users some of them to participate in some of the systems, others you don't allow them to participate on them. So it gives you a lot of control over what you're doing. You could think also if you have a building and you have various rooms in which you're using Dante to make presentations, each room could become a Dante domain manager, and that would allow you more control over who can use the system in the room and what can they do when they are in that system in that particular room. The Dante Domain Manager gives you the ability to create and manage the domains. It allows you to do this through subnetting, and it gives you a lot of information. It gives you dashboard and alerts. It gives you an audit log, so it allows you to see what happened in the system. If you need to find out who used the system, what did they do with the system. It allows for the automatic discovery of Dante devices, and it gives you a lot of control over the users, what can they do, what is their role. It also does system backups. It does encrypted traffic, and it allows you to route between the Dante domains. Now, this software is not as intuitive as Dante Control Manager. It needs a little bit more, let's say, learning and training in order to utilize Dante Domain. But at the end of the day, it has screens like this one, for example, that shows 6 domains that were created in this particular company. It has one conference room, another conference room, an auditorium, a production studio, a system that shows audio or presents audio in the lobby. It has also a boardroom. Just looking at it, you see that the device in the boardroom is offline. It's not being used in this moment, and all the other domains are actually active. And it shows you that in all the domains, the clocking, the connectivity, the latency, and the subscriptions are green, meaning they're ready to go. So whoever is in one of these domains could be using Control Manager to control what happens in that domain. And if they have the right level of authority on the domain, then they can actually select sources, they can change things. It gives you a more granular control of everything that is going on in the system. And very recently, in April this year, Dante Domain Manager also released an API. The API, for those that have people on their team that work with APIs, is built on GraphQL, and it can interact with the most popular systems to create API requests, which is the way that the applications communicate with servers. And they also created compatibility with Creston panels, with AMX control modules, with BitFocus Companion, and they keep adding compatibility. So in a few words, with the API, that allows Dante Domain Manager to introduce third-party control of the systems. That means that once you have the Dante system, you could now use a Creston panel with that API to program the Creston panel to control that Dante system through Domain Manager. This is a very interesting development that Dante had. It's fairly new, like I said. It just released in April of this year, and I particularly don't have a lot of experience with it yet, but I heard good things about the control that it gives you, the possibilities that it gives you. And if it's not yet compatible with the systems that you typically use, I'm pretty sure it's going to happen in a very short time, because Dante is releasing updates to that software constantly. In the PDF that will be provided to you for this presentation, I did include in there the links to the most important training and documents for Dante. I do recommend that anybody that is going to work with Dante go to Audinate and do their level 1 to 3 Dante AV and Domain Manager certifications. It's absolutely free. And then I also indicated the address to get the Dante Controller User Guide, the Dante Domain Manager User Guide, and the API User Guide. So those 3 links that are there are on the PDF, and you can actually use them to reach all those documents. Finally, I said that AES-67 is your friend. For many, many years, different proprietary solutions transporting audio were not able to talk to each other. People did not like that. And AES-67 was created by the Audio Engineering Society to allow different solutions like Dante, Livewire, QCs, Ravenna, WidNet, and others to talk to each other, and that today is a reality. You need to enable AES-67 capabilities in both systems that you're trying to communicate to each other. What they do is they restrict the menu of options to a reduced number of options to allow for that compatibility. For example, in Dante, they eliminate the 192 kilohertz. If you do 192 kilohertz, good for you, but you're not going to be able to talk to QCs, or you're not going to be able to talk to Ravenna. But as long as you limit your menu to the recommendations of AES-67, you can communicate between audio transport systems on the network without any issues. So the question will be for you, why are you going to use Dante? Well, because it's a very popular standard protocol for distributing digital audio over standard Ethernet networks. It is very easy to use. The Dante controller software detects everything, makes it easy for you to route everything, and it's a free downloadable application. It is very versatile. A Dante system is very scalable. You can start with just 2 ports and then go to 4 and then go to 6 channels, 8 channels, whatever you need for your particular application. You can also start small to learn how it works and then scale it as you need more, let's say, connections. It works in Windows and it works in Mac. So there's no problem with integrating the software either in Windows or in Mac. And it is economical in the sense that, like anything that we do on networking, you only use one cable, and in one cable you get the data, you get power because Dante supports PoE, and you get control because you get the Dante controller that controls your system. So we're very proud at MuxLab to offer you a complete ecosystem of solution for Dante. So with Dante, we offer you speakers that are Dante capable and ready. We also offer you the encoders that will allow you to encode an analog audio signal into your network, and also to get the signal on the network to be utilized in any way you want. We also offer devices that allow you to input and also output, so input-output interfaces. We have wall plates that work with Bluetooth or with a connection to allow you to bring Dante into that system. With the Bluetooth, it's especially interesting to bring audio from mobile devices. We have a DSP that allows you to do basic digital signal processing before you actually take it to the amplifier or to the speakers. And finally, we also have an amplifier that we can provide to your system. So you have a complete solution for your needs. Essentially, I'm going to show some diagrams of the applications with the different components that I just mentioned. This is a dual 2-channel or quad single-channel input-output that also works with PoE. So in here, you can input any audio source. You can input 4 mono audio sources or 2 stereo audio sources, and that will go into the network. But you can also bring information from the network into the device for output. You will always have the Dante controllers sitting in your system, doing all the connections, the routing, etc. And you can actually be sending then that signal into a Dante audio mixer. You can be sending it to a Dante speaker that's already capable of outputting a Dante signal without needing an extra amplifier in the system. Or you can use that device for input and output. So you can be inputting signals, but you could also send the signals back to the device, and from there you could go to amplifiers, and from the amplifiers you could go to the speakers. These amplifiers could be Dante amplifiers, they could be audio regular analog amplifiers. So the amount of equipment that you can connect to play with is unlimited really, and it all depends on how many channels of audio you actually want to handle. We also have very, very convenient, relatively small form factor audio encoder and audio decoder. So this is a 2-channel. It can then encode 2 mono signals or 1 audio signal, and that will allow you to bring that signal into the switch. And from the switch, again, you run it through Dante controller to make the connections, and you bring it out to Dante ready in this case, the speakers. Or you could actually be doing a decoding. So once you have put the signal into the switch, you can decode the signal to analog, and then you can use a regular power amplifier with the speakers that are not Dante ready. So you always have the two options. When you get the signal out of the system, you can transport the signal as a Dante signal and put it into Dante ready equipment to present the signal to the user, or you can actually use a decoder and take the signal back to being an analog signal and use a traditional audio signal carry channel to handle your signal. So in case that your audio comes from a laptop, for example, and that laptop has a USB connector, or your audio source has a USB connector, we can also provide you with an encoder decoder that is USB ready, so you can put the signal as USB into the Dante network using a USB encoder. You can get the signal out of the Dante network using a USB decoder if you actually want to put it back into a device that can understand USB. Or you can take the signal once it's in the network into speakers, and again, always a laptop with Dante controller sitting on it. The wall plate, it's an interesting piece of equipment. We have two versions. One of them is a simple Bluetooth connector, so you can have any equipment that can communicate with Bluetooth, send your audio from the device, maybe a smartphone, into that wall plate, and the wall plate will encode it and turn it into a audio Dante signal that can go into the network. We also have the capability of allowing you to do a regular analog audio type connection into another type of wall plate, and again, that would allow you to bring the signal in, and you can also do it with the USB. So there are many options that you can do to get your signal into the system. I particularly like this one that allows you to bring anything from a mobile device that is Bluetooth capable into the network with a very, very small factor, not intrusive at all. People don't even notice that you have it in the system. Once the signal is in the system and you need to take it out now, you can use a Dante amplifier. So that will actually allow you to take the signal and do whatever amplification is needed still in the Dante domain, and then finally to put it out into speakers that can be 70 volts or 7100 for distributed audio, or regular 4 to 8 ohms speakers. And we have also a digital signal processor that would allow you to play around and, let's say, tailor the signal to your taste before it actually goes into the world to be exposed. That digital audio processor will have equalizers, either parametric or graphic equalizers. It also has a compressor, it has a limiter, and it has kind of this interface that allows you to control that through a laptop or through an iPad. It also has a mixer because the digital signal processor has various channels for input. It can eliminate also different noises and create noise rejection, and you have total control of the level of the outputs that you're getting from the digital signal processor. So this was a brief introduction to Dante Audio. How does, first, how do we convert an audio signal into analog into digital signal? Then once we want to put it into a network, how do we use a solution like Dante to do that? And the next question would be, how do you implement a Dante solution? Well, for anything that you want to do with technology, you have to learn about it, and that's what we're doing today. The second thing that I always recommend to everybody is what I say: cut through the noise. Any manufacturer is going to put bells and whistles around their products and around what they are offering you, and it is important that you're able to understand how the product actually works, what the product actually does beyond the noise that we can make around the product. And more than anything is, what does the user need? Okay, At the end of the day, it's all about the application. What's the fidelity of the audio that you want? What kind of source the user has? Does it have an analog source? It's already a digital device. Do you need amplification? Do you want to go directly to Dante ready speakers? Do you want to go through a DSP to process that signal? Do you have the signal in a device that has a USB connection? Do you have a signal in a device that has a Bluetooth capabilities to connect to a Bluetooth plate? So it's all about the application. And the more complex your system becomes, remember that this is a team effort between AV and IT. Most of the time with audio Dante solutions, you can do it on your own. You can set up your own network and use it for Dante, and that eliminates the need to be dealing with the IT people. But be aware that as the system becomes a little bit more complex, or your customers are a little bit bigger, they may have an IT team that will get involved in anything that is required to go on a network. Thank you for your time. You can always connect with MuxLab's through Facebook, LinkedIn, and Twitter, or now it's called X or Instagram. And if you need to contact us, the sales team at MuxLab, that they will reply through this email. Here is also the phone contact. And if anybody would like any other information, questions, etc., please contact me at my email or by phone.